We are now going to do a brief review of quadratic functions. We're going to do 3 sections in the book that deal with quadratics. So today we're focusing on some really important features of a quadratic function whose graph is called a parabola. So I'll probably use parabola mostly. And we're going to focus on graphing parabolas. Okay, so this is all information about a quadratic formula. You have a basic form here, ax squared plus bx plus c. The graph is called the parabola. This is important to know. The x-coordinate of the vertex, I covered up the negative, is negative b over 2a. That's something you should know. And then also other important information, the standard form of the quadratic function. Once a quadratic function is in standard form, then you can read off the vertex. This hk is your vertex. What you minus in the parentheses is the x-coordinate. So it's the opposite of what you see. It's the opposite sign of what you see. And then what you see at the very end is the y-coordinate. So that's why we have a horizontal shift of k and a vertical shift of, a horizontal shift of h and a vertical shift of k. When the front is negative, when that constant value in the front a is negative, then the parabola opens down. So fill in that blank. Okay, so let's sketch a graph of this quadratic by putting it in standard form. I don't know if you remember this or not, but the way you get these beautiful standard forms in which you have a quantity squared, that also happens in some conic sections, is that you have to complete the square. So we're going to be completing the square. Okay, so first of all, the way I complete the square is this a value has to be 1. And if it's not, then I have to factor that out. I'm going to write y instead of f of x, which is just fine to do. Okay, so there are a couple of ways of thinking about doing this. Sometimes people add the 5 over to the left side. I'm going to just kind of ignore it for now. Okay, so I'm going to put it back here at the back. It's still there, but I'm not focusing on it. Instead, we have to add a certain number here. I call this number the magical number. And the magic number is negative b, well, I guess it's not negative, it's b over 2 quantity squared. B over 2 squared. It's really negative b over 2a. It comes from this x-coordinate of the vertex. But I always make a 1, and then a negative square is always positive. Okay, so you just take half of this b quantity here, square it. So half of 4 is 2, and then 2 squared is 4. It's always going to be a positive. Okay, then we're also going to subtract it because otherwise we've changed the function, and so it's no longer the question anymore, and the graph that we come up with is not the graph of what they're asking us to graph. So you add this magical number, and then you take it away as well, so that we didn't change. Notice that this equation here, plus 4 and minus 4 cancel, and you're back to your original question. Okay, so now I'm only going to focus on these first 3 terms. Completing the square is called completing the square because you get a perfect square. This will factor as x minus 2 times x minus 2. The same thing over and over again twice. Now I combined that thing at the back that I'm not really paying attention to, the minus 4 and the minus 5, into a minus 9. And so this is my standard form. I just write x minus 2 times x minus 2 as x minus 2 quantity squared. And so I know that my vertex is 2, negative 9. Notice I took the opposite sign of what was in the parentheses for the x-coordinate of the vertex, but I kept the negative for the outside, which is the y-coordinate of the vertex. So negative 2, 9. This opens up. Okay, so let's get a graph going. All right, so I've pulled up a coordinate axis to graph on, and I'm going to do a couple of points. So 2, negative 9 is my vertex. I'm going to start there. Okay, and notice I've chosen some values to plug into. Now, what are important about these values? They're close to the vertex, and they're the numbers you're used to graphing, but just shifted. So I took the vertex x and I subtracted 1 to get 1, and I added 1 to get 3. So when I plug that into this original I get 2 minus 1. 1 minus 2 is negative 1. Negative 1 squared is 1. Minus 9 is negative 8. And this is going to give me negative 8 as well. 0 will give me negative 5. And 4 will give me negative 5 as well. So I have negative 8. I went up 1, over 1, up 1, and then over 2, up 4. Which is what a graph usually does if there's no stretching and shrinking from the vertex. I should probably make sure I have these intercepts right, but I'm not going to take the time. I have some nice points there. Okay, moving on, here are a few more to sketch. I'm going to let you sketch this one, the f of x equals 9 minus x squared. I think you can handle that one. And then I'm going to do this one. Okay, so to sketch x squared minus 6x plus 16, I could put it in standard form, which I just did, but I'm going to show you an alternate way. Instead, I'm going to find the x-coordinate of the vertex. To find the x-coordinate of the vertex, remember there was that formula. It's negative b over 2a. And so here's my b, negative 8, that's positive 8, over 2a, a is 1. So I get the x-coordinate 4. I know that my x-coordinate of the vertex is at 4. Now I'm going to find the y-coordinate by simply plugging 4 in. Okay, so that would be 16 minus 32 plus 16. Is that 0? No, 6. Yeah, 0. So 4, 0 is my vertex. And then this opens up. I'm going to do a real simple XY chart. So let me do 3 and 5. So at 3, I get 9 minus 24 plus 16, which is 1. I meant this way. And I think at 5, I'll get 1 also. And then I think I'll get these points as well. Okay, so that's an alternate way of sketching the graph without doing the standard form. Also, I'm going to give you a little trick here. Do you remember that the standard form is, and I do recommend you memorize this equation. So this A, by the way, is the same as this A, this 1 that's here. That A is always the same. And then H and K are the vertex. So I completed the square last time to get the standard form, but really I could have just used the vertex. So this is just y equals x minus 4 squared. Oh yeah, look at that. That factors perfectly. So that's sort of a sneaky way of getting the standard form without completing the square. Is to just know the vertex and then plug it into the standard form and your A. Okay, so this one here, I'm going to let you guys graph this one also. Notice you have the vertex, and be careful, your A is negative, so this will open down. This example, I'm going to work with you. I am going to go ahead and put this in standard form by completing the square. I actually think that completing the square is probably going to be easier than doing that little trick. Because when you factor the 4 out, it makes this a little bit nicer. Okay, so I've set this up. I'm going to add my magic number here in this blank, and then I'm going to subtract it away in this blank. But you have to be very careful about how you do that, okay? Oh, it's a fraction. So notice that b is 1, so I'm going to add 1 over 2 quantity squared. So that's 1/4. I'm adding a magical number of 1/4. And when x squared plus x plus 1/4 factors, it factors as x plus a half quantity squared. Whew, this is an awful, it's just a unique example. Kind of fun. All right, now when I subtract that magic number, I have to be really careful because yes, I see this 1/4. I added a 1/4, but be careful. That 1/4 is in parentheses, and every number in parentheses there, every term in that parentheses is getting multiplied by 4. This isn't x squared plus x. It's really 4x squared plus 4x. So I have to be careful. I did not add a 4th. I added 4 times a 4th because that 1/4 is in these parentheses where I have a 4 times on the outside. And so then 4 times a fourth is 1. And so this is minus 20. So this standard form is y equals x plus a half quantity squared minus 20. And on this graph here, if I make the y-axis go by 2's, then, and I make the x-axis go by 1's, then I have my negative 1/2, negative 20 as my vertex. So negative a half, negative 20 is all the way down here. And this opens up. So instead of going over 1 and up 1, I would go over 1 and up 4 because of that a that's 4 there. And then over 1 from a half is not very pretty. So I'm just going to go ahead and I've got 3 nice points here. There we go. I am not sure where I crossed the x-axis. Okay, so let's talk about how to graph a little in another new way. Okay, so I'm changing this. This is 2x squared minus 3x plus 1. On every single one of these graphs, I have been playing very fast and loose with intercepts. But I'm going to show you how to graph a quadratic function using intercepts. And usually I'm very much a stickler about intercepts. I like the intercepts to be right. So I'm going to find the x-intercepts of this. X-intercepts. Something we've done before. That means that the y value is 0. And so I'm setting 0 equal to 2x squared minus 3x plus 1. I changed this for a very good reason. Now I factor nicely as 2x minus 1, x minus 1. Now that I can use this zero product property and set both of these things equal to 0. And I get here that x equals a half. And over here, x equals 1. And so, wow, let's make this 1, 2, negative 1, negative 2. So now my intercepts are a half and 1. Okay, and I show you this way because it's easier to, it's just a different way of doing it. But I can find the vertex also. The vertex will always be halfway between the intercepts. It's because of the symmetry of a parabola. Always halfway between the intercepts. So halfway between a half and 1 is 3/4, unfortunately. So x equals 3/4 is the x-coordinate of this vertex. And I've done the arithmetic here. The y-coordinate will equal negative 1/8. And so 3/4 negative 1/8 is there. Okay, and then you can just put in your parabola from there. All right, I moved on to the next page. This is our last example. What we are going to be doing here is working backwards. Determine the equation of the quadratic function based on the information given. So I have a big picture of, or big axes here, and all I've been told is the vertex and a point on the parabola. I'm not going to use that graph. I'm not going to graph this. And well, I might as well. 2, 3. That's here, and the point 0, 2. That's there. And so if this is the vertex, we can see that the graph is going to open down. So I know a is going to be negative. I don't know what a is, though. I'm going to go ahead and use standard form, a x minus h squared plus k, because I have hk. And so the only thing I have left to do is figure out a. Okay, and how do I figure out a? Well, I use this other point. This other point tells me a relationship. It tells me that when x equals 0, f of 0 is 2. So let's use the fact that f of 0 is 2, or y is 2 when x is 0. So I replace x with 0 and y with 2, and I get an equation, and the only thing I don't know is a. So this is a times 4 plus 3. I minus 3 from both sides. And so it turns out a is negative 1/4. And so my parabola is f of x equals negative 1/4 x minus 2 quantity squared plus 2. And that fits with the picture. I know it should open down, so I got a negative a. That's great. That 1/4 just means it's going to be fatter. And it is. So there we go.